Hi all, welcome to my channel. In this video, we're going to discuss about thread safety, which is the ongoing series of Java concurrency in a new way. So previously, we also covered like many videos on like deadlocks, producer consumer problem, and how to create threads, all the stuff. And today we're going to discuss about like thread safety. So let's dive deep into what exactly thread safety is. Yeah, so in the concept of multi-threading, where multiple threads keep on basically access the objects, share the data, right? So we need to create objects in a most safest manner so that it's basically safe when multiple threads are parallelly trying to access the data or trying to replace something or trying to add a data into those objects. So for example, in order to ensure that like multiple threads access the data without leading to inconsistencies or any corrupted data, like our main goal is to basically to remove all inconsistencies and also all corrupted data to make data as a secured. So let's consider a real world scenario. For example, imagine, you have a bank account. Assume you have a joint bank account, like where you have some amount where basically two or more people can have a owners of this account, right? So now what you can do basically, let's say you went to the, let's say you and the joint account owner went to, let's say, bank account and parallelly trying to withdraw money, like, or ATM, basically parallelly trying to withdraw money or like take the money. So now what will happen if it is not a safe object? For example, balance should be something like safe object, right? Your bank account object should be very safe. It should basically tolerate the multiple threads accessing the data, like. So what will happen initially? Two people will basically check the data, check the amount. So two people will basically get the amount as, let's say, 5,000 in your bank account, and two people will start withdrawing the amount, like. So ideally, only one people can withdraw the amount as soon as the balance basically zero or balance whatever they're trying to withdraw, which is basically not enough, not a sufficient balance. It should basically stop preventing of withdrawing, right? Otherwise, it would lead to the overdraft. So we should basically design a, so is it possible that multiple people parallelly try to access the same object? So which means whenever multiple people parallelly tries to access the same object, here in this case that a joint account, we should make sure that's basically thread safe. So which once it is thread safe, so multiple people parallelly can take the amount. So and also everything can go in a sequence way. So once the first person basically withdraw the amount, and second person shouldn't basically withdraw the amount because of balance went into zero. So yeah. So how can we make sure that basically when we should basically worry about objects, right? There are like two kinds of objects. One is basically mutable objects, and second one basically immutable objects. So what is mutability, which is basically changing over a period of time? So for example, you declare something, right? You declare a variable, and you can basically change that variable over a time. Like for example, in this case of balance, right? So set balance, you can change the set balance. So you can update the balance, for example, either a deposit method or a withdraw method, right? It is possibility that you're changing a field even though after creation. So initially, whenever you're opening a bank account, it is basically zero, right? You'll keep on gradually update the value. So these are basically mutable objects which are basically changed after creation also, like. For example, best example is basically string builder, right? In string builder, you keep on append the object, right? You keep on perform dot append operation, like, and it basically try to create a string from that. So whenever multiple threads can access this string builder, it is possible that if you're not designed a thread safe environment for this particular object, like dirty reads or dirty writes can happen, like. What is immutable? Immutable means once you defined, it is final. You cannot even change. For example, here best example is strings, right? Strings are always immutable, like. So which means like once you define a string, for example, string username or a string password, that's basically immutable. Like you cannot change that field in any of the methods. you should basically create a new string. Then only you can change that new string one, but you cannot override the existing string. So when you try to override existing string, it will always show, it will always says that but you can only override, but you cannot modify that one. So overriding is nothing but creating a new string itself, right? So that's basically string is an immutable object. So one thing clear that if you create an immutable object, then it's a kind of a thread safe environment. You can use that object in thread safe. Otherwise, you have to perform some operations on top of a mutable object to make sure it's a thread safe. Consider a real world scenario, right? For example, you have a configuration data with you. For example, ideally, right, configuration is the same across all the users who are basically accessing your application. So it is making sense that keeping that configuration data is a immutable, like a fixed one, so that any number of threads can access that data. It's always a read operation, right? You can always perform a read operation, can access the data without any worry. Like, so this is the one scenario, like or having a immutable object in real world scenario. So let's see, for example, how for immutable objects, how to make a thread safe. So first thing is basically try to make as immutable as possible. For example, you're creating a class. Try to create a class as immutable object. So, and if immutability is not working, then try to if you are performing any write operations, right? Try to keep in a synchronized blocks. We'll discuss very in depth about synchronized blocks in my future video, in my next video itself. There we'll discuss about like object level synchronization, class level synchronization, like many problems, many use cases also. But for now, understand like immutability is the first key comes to your mind to make the thread safe design. Second thing is basically apply synchronization blocks or synchronization level to restrict only one thread can only access. And third one is basically locking. Locking is a more robust compared to synchronization and it will basically provide a more locking mechanisms, like either you want to lock the object only on writing or you lock the object on reading. How far you want to lock the object, like all these time sensitivity, everything comes into the locking. Like, so there are multiple lockings are there. Once we're done with the synchronization of video, we'll discuss about like locking as well. So these are like three different main strategies to build a thread safe design. And if you keep the field as a final, right? That's basically it's a final. Like you cannot modify that thread. You cannot modify the variable once it's already defined. So that's how basically we define it. We prevent the we convert the mutable to the immutable object. Like, so second thing is basically volatile keyword. We'll also discuss difference between the volatile keyword and atomic integer, and also this what is the memory visibility problem, and what is the advantages or disadvantages of volatile over the atomic integer. We will see very in depth. For now, you can think of like volatile keywords basically ensures that all the changes you are performing an object, it is visible to across all the threads. That visibility is basically guarantees by the volatile. But what it not guarantee, we'll discuss in the future videos. Like, so utilize the final keyword to create an immutable object, and also use volatile wherever we required. You make sure that this thread data will this particular data should be helpful. Should be known by across all the threads. That's where you will keep the volatile. So we'll see we'll see the live demo how to make the class as immutable. So in future videos, we'll basically see synchronization blocks and final and also volatile atomic very in-depth blocks also. Like, I think these are the previous video things, right? Now let's create a thread safe class. How can we create a thread safe class? Among the strategies of listed thread safe class, right? The first thing is basically an immutable class. Try to create an immutable class. Let's define an immutable user. So let's define a basic things like, for example, user might be have integer user ID will be there, and it can be string name will be there, and also, for example, user might have a list of preferences. Maybe like you can say it as string for now for simplicity. You can You can mention as a preferences. So now let's generate so can we I think for initializing an object itself we can while initializing a constructor, right, while creating an object itself, we can basically include all the fields to be created, so that in the future we no need to basically remodify again. This is the first way of basically preventing the making the classes immutability. Like you can declare a constructor, under constructor you can pass everything, so that's basically has a immutable user which will pass everything. Now is this basically enough for immutable? Let's test this one. Like let's create a driver method and let's have a main. Let's say immutable user equals to new immutable user, right? So for example, 1 comma, I can give my name. So I can give my name. So comma, let's create a list. List of strings. Prefs equals to new sorry. Okay. List of strings is to new array list. So let's add a normal add one, right? You can add into the prefs. So now it is basically immutable user. Let's test. Like, see, you can still access the name and override the stuff, right? So for example, let's build a object, right? Let's build a toString to define even more better. Okay, let's define a toString, right? Okay, let's define a toString from all the values. Now basically if you basically print, right, immutable user, automatically your initial name which is basically my name will be updated to the name s. Let's see. If you see, my name was basically overridden, right? This is not an immutable. So what you can do, you can basically mark it as everything as a private. So if you mark everything as a private, what will happen? So this you cannot access like these variables, right? So now you can still you shouldn't basically overridden, but you can still access. So that's why I'm creating the for a futuristic purpose, like to store the DB, to send it to the another service subsystems. So for thing we should require the getters, right? Setters shouldn't require, because setters basically explicitly you are asking to modify the outside object. For a immutable class, setter shouldn't be happen like. So now basically we have this one, right? So we have a driver method, everything is working fine now. For example, immutable object dot get preferences, right? Let's see this is basically immutable or not. This list is immutable. List is not a primitive data type. Like primitive data type, you have basically stopped with the private method. But let's see whether this string is basically changing the value or not. Like I'm basically adding the another preference. I'm basically performing now. So now what it will happen? It will try to add it to the object, because whenever you are returning to the getters, you are returning the whole list object, right? Which means you are able to providing you are accessing this, you are giving this object access. So inside that one, it will basically try to add. So in order to prevent this one, to make this list is also immutable, we can create a new array list every time it basically returns. That will make sure that only this whatever this object is basically constructed, only that thing will be returned. For example, now if you run this driver method, right? What it will happen now? So it won't add the add to it, only add the add one. So which is basically truly immutable, like. So you can mark it as everything is a final to explicitly mention that these things won't be changed. So now your object is basically truly immutable, but your class is not immutable, because this is not a final, right? You can basically extend this class and modify the inside properties also, like. So you can basically mark it as a final to explicitly make sure that this is immutable user and no one can basically perform inheritance also, like. So now this is basically thread safe. It will only initialize the object only once, your object only initialize once, and later you can only perform the get objects only. Like see, it also mentioned like you can only perform the get objects only, and n number of threads can access this particular object. Like even though n number of threads can access this particular object, it is still is an immutable only. Like so you cannot it's only all read operations that there is no write operation is performed. So it's a basically a thread safe design. So second level can be sometimes it is required to change the object, right, during the by the outside of other services. Like that's where you need to take a little bit of conscious that making sure that only one thread can only access a particular object. So either making that as a synchronizer block or keeping or applying the logs. So we will see very in depth of real world scenarios of about like a synchronization and logs also in future videos. But for now, let's see this is the how to make a thread safe design. And the first step is basically making as a immutable. Like yeah, I think that's it about today's video. Like the next video we'll discuss about like synchronized blocks, and the next video we'll discuss about like Java logs as well, very in depth. So if you like my video, so please like and subscribe and share to your friends. So the next series of the next 10 videos also most valuable videos when it comes to Java concurrency, where I'll basically teach everything in depth and most demoable way, and all the real world scenarios as well. So we'll soon meet in the next video. So till then, bye bye.